Welcome to the crucial step of implementing attributes in SQL, transforming our conceptual design into a logical database schema. In the, implement entities step, conceptual entities like passenger or booking transform into database tables, and their attributes become columns. Attributes are categorized into singular and plural types, which dictates how they are implemented in the schema. Singular attributes, those with a single value per entity, simply remain as columns within the initial table. Plural attributes, however, those that can have multiple values per entity, move to a new, dedicated weak table. Let's focus on how to correctly implement these plural attributes to maintain normalization and data integrity. A new weak table is created to hold the plural attribute, along with a foreign key that references the initial entity's table. The primary key of this new weak table is a composite key, made up of the plural attribute itself and the foreign key referencing the initial table. If the entity is passenger with plural attribute phone number, what would the new table name be? Understanding naming conventions and alternatives helps simplify our database design. The standard naming convention for this new table is combining the initial entity name, like passenger, and the attribute name, resulting in passenger phone number. If a plural attribute has a small and fixed maximum number of values, you could implement it as multiple columns in the initial table. However, creating a new table usually simplifies future queries. Which approach would you choose for a plural attribute, like email address? Next, we map our conceptual attribute types to specific SQL data types and implement cardinality constraints. Conceptual attribute types like name_string map to SQL data types such as varchar, and date_date maps to date. Attribute names often include a type suffix to clearly indicate their data type. What SQL data type would you assign to an attribute type amount_currency? Required or unique attributes become not null and unique columns respectively. By default, columns are optional and non-unique, unless marked with R or U during conceptual design. If a foreign key references a required entity, what constraint must be applied? Finally, we translate our table diagrams into executable SQL create table statements. Required columns are specified with not null, and primary keys are explicitly defined. Foreign key constraints include cascade and restrict rules for data integrity. Here is an example of the SQL code for the passenger phone number table. When dealing with composite primary or unique constraints, additional clauses are necessary outside of the column definitions. Which clause would you add to enforce uniqueness across two columns? Implementing attributes correctly ensures that plural attributes, types, and cardinalities are accurately represented in your SQL schema, completing the transition from conceptual to logical design.